So hello everyone, my name is Cauê de Moraes Bustena, and as the chair of the session and presenter, I'm now introducing me again, presenting my work that was developed in collaboration with the Federal University of Paraná, my university, and the Politecnico di Milano. I've been there for 6 months developing a part of this work there. That's a work that is still going on, okay? So the title of the presentation is Deep Pavements Framework, a project and open source framework for OSM compliant pavement identification using AI. So let's go forward. So first, I need a little bit about me. So I'm a cartographic engineer, a master in geodetic science. Now I'm doing a doctorate, a PhD at my university. I'm OpenStreetMap user since 2014 and also a cyclist. So that's the reason I got interested on accessibility stuff. And most of my research is around that. So I developed other projects like the OSM Sidewalk Creator, QGIS plugin. I have a workshop about accessibility mapping. And last year, Kosovo was presenting Open Sidewalk Map. And as you guys can see, there's not too much info about the pavement types, okay? So let's do some little small introduction. So we can speak about accessibility and the SDGs of the United Nations. So at least we can link accessibility with good health and well-being and climate action because it's a non-pollutant and active way of transportation. It means inclusion, so it impacts on the number 4, number 8, number 10, number 11, of course in the end from 17 and maybe for more than just those ones that I cited. And then let's speak about the capacities that are unlocked by doing detailed mapping. So we can report, we can have public scrutiny, you know. We can optimize using just what I got, and we can plan ahead in an optimized way. So we can go from this sheet for a proper pedestrian routing, because pedestrians are not walking in the middle of crossings of the roads, okay? And in many places, as you guys are about to see, it's not the same thing to walk in the left side of the sidewalk and in the other side, you know, like this. So this is quite very interesting for the motivation on the presentation, and this one is quite symptomatic, okay? And then when we analyze the pathway data and the surface data in the OpenStreetMap case, we can see that when we compare the highway, the lines with the highway key and the surface key, just 27% got a surface tag. So we have lots of features without this information that is fundamental for reaccessing the level of accessibility. So considering this lack of data, from where can we extract more data about surfaces that are one of the first subjects when we consider accessibility? So we have street-level imagery. So we highlight Mapillary, that is the database that we are using right now, that got more than 2 billion imagery with Creative Commons license. But we can also highlight Panoramax and Wikimedia Commons and other solutions that also have similar licensing. So we can state the research problem that we have 2 questions. On which side there is a sidewalk, and what is the pavement type in them, plus the street. Okay, so we want to know the pavement types of the sidewalks and also the street, because the street is also part of the pedestrian network because they need to cross the streets. And then when I started to read the bibliography, there's just a few authors on the subject, and they have many problems, like they just use few classes, it's all car-centered, so no classification on the pavements of sidewalks, just roads. Like few classes is just generally paved and unpaved, and we know that it goes far beyond that. It lacks any sort of standardization, and most of them didn't do pixel level segmentation. And then there is one author that does a very nice job, but the classes are the New York, or are too New York oriented. So if I want to use that here in Brazil, there in Europe, you probably are going to see different types of pavements, and they are not following some sort of standard. So let's speak about the development. So going back after all this introduction, Git Pavements is a modular project that is hosted on GitHub, that it got many modules, like more can come, but right now we have something like the data set with 5,000 samples more of surface patches. We have the sample picker, that's for you to produce samples, more samples. The runner, where it generates the final data that I'm going to show you afterwards. And the deep pavement slides, that is a version that just do the stuff more straightforwardly. Okay? And there's also a module for labeling samples. So we can state the modeling as an ontology. So the classes that are used for pavement classification are following this standard on OpenStreetMap, that is a community standard that it was built inside the community along in the last 2 decades. Okay, so the data set got these categories there, and we can state the problem that we have. Like all it all starts with pathways, that is this, I forgot the word, but is this, the opposite of concrete is abstract class, that it can be derived on footways and side paths, and in the end we got roads and sidewalks with their topological relations. And in the end, all pathways contain as a property the surface materials, and then we have the taxonomy for all of them in categories like unpaved, continuous paved, and block-based for the paved case, and so all of them are asphalt, cobblestone, concrete, compacted concrete plates, grass, gravel, ground, paving stones, and sand. So for the development of the framework, the design principles are like complete obvious. Of course, this is FOSS4G. Couldn't be other way. The ease of reproducibility, aka we are using Docker. All the modules are basically Docker images, so you can, with few command lines, you can just do the whole thing. It got evolvability. That is the thing. We are using a particular set of algorithms right now, but they are always evolving. So the idea is to, with the time passing by, keep the same Docker images, but maybe with new building blocks. And they can be updated while the interface is kept, okay? And also, as I spoke before, standard anchored, using the OpenStreetMap standard for the pavement classes. So let's talk about the implementation of it. The algorithms that are using right now are like open vocabulary arguments. That means that they are visual language models, that they have visual language model inside the same algorithm. So rounding is the one that identifies the bounding boxes and segment anything, picks up the bounding box as an input and produce the zero-shot visual instance of what you did as a prompt, okay? And then there's the algorithm clip that is used for a constrained open vocabulary image classification. Let's show an example. So if you pick like this picture that I believe that is from Italy, you have first, you ask for sidewalk as a prompt, like because it used the visual language model. And then you have the candidate segmentation, and as it is also language model, it can hallucinate. So you use a second algorithm that acts like a goalkeeper. And then if it isn't a pavement, it just throws it away. But if it is a pavement, it classifies as according to the categories on the OpenStreetMap standards, right? And the command line interface is still a work in progress, but kind of same old, same old. You just put a bounding box, and you're going to download all the Mapillary imagery inside the bounding box. It will do that algorithm, and in the end will produce some data points that I'm about to show to you the idea. So, but before that, let's show a little bit of the results of doing the fine-tuning for the clip model on doing the classification. So when we tried to do the classification using the initial clip model, we got this very limited result. And then we did the fine-tuning using the data set, and then afterwards we treat the hyperparameters, like we slow down the training, we slow it down the training rate, so it reduces the size of the gradient vectors to find to not end up in local minima. That happens in some trainings like that. And then we got a better result for the ones that are not familiar with this kind of table. It's like this is the class one we have, and this is the prediction. So the more main diagonal predominant, the better the result. Okay. So the final goal, that's still just planned by now. Okay. It's like this. You have the image and the detections of the sidewalk alongside the type of pavement becomes a data point. Okay, so each image can generate 1 or 2 data points. Okay, so in the end, you can just do Voronization. You can just transform the points into Voronoi polygons, and then you dissolve, and then you can just conflate the information about sidewalks with information about the pavement types with existing sidewalk or road data. Okay. And so the conclusion, this is a further development on this paper that just arrived. Okay, so it was published on the International Journal of Geoinformation. That is a paper entitled Investigating the Performance of Open Vocabulary Classification Algorithms for Pathway and Surface Material Detection in Urban Environments. If you guys want, you can read it, and it goes more deeper into the limitations of open vocabulary algorithms. And some final remarks about the presentation is like the deep pavements, the framework that still doesn't have too much of a face, but it's a modular open source tool set for mapping and classifying urban pavement surfaces. It's hosted on GitHub. This is the main repository where you can find the links for all the modules on the project. And also, of course, it's open for collaboration and improvements. It's integrated with OSM, so it generates the data that's aligned, it's compliant with the OpenStreetMap standard. So it's going to be ready to be like uploaded or to be imported for OpenStreetMap. Yeah, this was supposed to not be here. It's the second one, but for future enhancements, we are trying to improve the image quality filters for reliable classification. So now we process all the Mapillary data, but sometimes you have like some lousy images, like some that are quite not very, yeah, how is that when you have many lines that you can see them is, I forgot, when you can distinguish between the lines easily, that is, yeah, like this, like we can see the separation of them. I forgot the word. Não. É nitidez.
They're not as clear.
Não, tem uma palavra, tem uma tradução de nitidez assim. Okay, never mind. But to filter out the images with the worst quality, okay? Since it's a database that is contributed. To detect also to detect pavement decay, so that we can use the OpenStreetMap smoothness tag as well. So we can end up with surface and smoothness. It's a step ahead on assessing the level of accessibility of pathways. And also to integrate photogrammetry for precise 3D modeling. So in the end, it would be like surface, smoothness, and width. That is another, and also ideally also the incline, and mainly the incline not in the sense of walking, but the incline in the across track that sometimes is a problem. And with 3D data we can extract that information. So from the pioneers of open source, thank you all, and you can find me on LinkedIn or at Caulivestena in many places, maybe not that much in the almost at Twitter, but you can find me on Mastodon, and of course, to be reachable by all ages, you can you can find me by using my email. This is the QR code to the main repository, and yeah, that it is. Thank you all.